Buongiorno, come va? That's how. That and maybe ordering pizza or pasta is as much as my Italian goes, so sorry for that. Some of you will know who I am. I have a quick question. Who has seen me on a YouTube or other video platform already? Okay. Another question. Who has read a book that has my name on the cover? Or at least has it on a shelf or seen it somewhere? Okay. So for some of you, I'm brand new. But for all of you, I will be an old friend after my talk because I'm talking about my experience of the last 30 plus years. And I figured out, oh, it's 2018. It's 35 years of programming. 35 years ago, I wrote my first own program on my own. Cool, huh? The problem is, you recognize you're getting old when you tell stories about the past on programming, on computer science, and figure out, oh, your students haven't been born then. And for the title, I thought, okay, I played a role in Agile and patterns and C++. But APC just didn't make it. And I like driving cars, so I just make it ABC and inserted BMW in between, and I'm not sure if that was a good idea. Actually, what I'm talking about is more like a full alphabet of stuff, from Agile to zero-terminate strings that we just learned about from the example code that was wrong. And I even figured out I contributed to most of that stuff, not everything, like garbage collection is something, who knows how big, or let's say, how to recognize C++ garbage collection. Very old joke, curly brace. That's the one character, most powerful thing in C++ garbage collection. Okay, what else? 35 years of programming, and that is my first car, not a BMW yet. And this is how I looked like. So it's, you see what 35 years might make of you. And actually, I'm lying, that might be a little bit later than at the age of 18, but the car was definitely at the age of 18. So my very first program, at the last year of school, so gymnasium, I took a math elective course. We had, in Germany, we have that system where you have majors and then minors, and you can take a minor course in your major if that's not related in subject to the rest. So I took a math elective on programming. And the thing we were programming on was a pocket calculator. The most popular then was among friends who could afford it was the Texas Instruments. But the school had HPs for rent. So HP 33 or 19, which were almost similar, just the slightly different thing. And the thing was, in school, all the fellow students actually had these Texas Instruments programs handwritten on paper that they did and maybe copied from a magazine and typed into their pocket calculator to play Moonland or whatever. And they wouldn't work on the HP. Well, the thing is, the HP has a stack and a completely different set of instructions, but the concepts of programming were universal. So I started out to port the Texas Instruments programs to run on on the school's HP pocket calculator, which was quite challenging because everything had to fit in 50 steps or 50 memory locations that were programmed, the size of your program, which is quite good if you need to type it in each time you want to run it. And after having successfully ported my first program from the TI to the HP, I wanted to invent my own game. So it shouldn't be too big, and it should work somehow. So I invented a game of ballistic shooting. And to make it more interesting, I put up a random distance to hit your target, and I put up a wall that you have to actually cross, and what you would enter was the initial velocity and the angle to shoot from. and not considering any drag or so, a planet without air. And so you have to figure out the angle to actually cross the wall and velocity and then hit the target. So it's kind of a, if you do it cleverly, you do kind of a binary search and will hit it in a couple of steps. The thing is, I was okay with it, the program worked, and everybody forgot about it. And then came this. I said, oh my God, I could have made a fortune out of my little first program. It's exactly the same idea. Select the angle and the velocity and shoot at targets. It's just a little bit more graphics involved, and I'm sure more than 50 program steps. Lessons learned. I will sprinkle those lessons learned. I learned to mentally execute code because you couldn't debug on a pocket calculator then. I learned using a stack, which was a very, very great benefit for me later on. I learned to read foreign code in a language that I couldn't even execute or try. And I learned porting code, which could even be fun. And in retrospect, I learned very old and simple ideas can actually remain useful and become very successful if executed properly. After graduating from gymnasium in 1983, I took a vacation job or a break job, and from the first money that I earned there, I bought my very own first computer. I couldn't afford the Commodore C64. Who has owned or used the Commodore C64? Oh yeah, all the old peoples. So for all of you who have no idea what a Commodore 64 is, go to retro computing and figure out what that is. This was the budget model, which was actually slightly more powerful from the processor part. It had a Z80 which had real registers, 16-bit registers, not only this accumulator thing of the C64. But it didn't have a real keyboard. It has little rubber things. And therefore, it actually accommodated typing by having actually keywords per key press, which meant you press the print key to get the print keyword. And you see all these, maybe these colorful little words written on top and bottom of that. So I also learned how to have a multi-layout keyboard and press the right shift key at the right moment to actually get into the mode, to get the right keyword or the right thing on programming. The thing was, the Spectrum worked well on my TV set that I got from my parents because I was about to move out to start university, so I had some entertainment, and with 3 channels in Germany at that time, it was a little bit boring just having a TV, but the computer helped a lot. And now, how do you store, you could actually type in your program as with the pocket calculator, and when you turn it off, or wiggle the power cord, it was gone. So you stored your program on things like that. Cassette recorders. Who has used in his life a cassette recorder? Okay. Who has never seen a thing like that? It's a cassette tape recorder. It's the MP3 player of let's say, the 80s. I even had a Sony Walkman that time. But the thing with the cassette recorder, it usually came with 90-minute cassette tapes, so you make your mixtape for your next girlfriend to show off what music you like, or share the sound with your friends, or have parties with the best tape selection. And the problem, 90 minutes of program code is quite a lot. And it was kind of a 1200 bit per second beeping noise that made your programs store on the tape. And finding the programs was really a challenge. So some people actually made money by selling data cassettes who actually were only 5 or 10 minutes long. So you only had a few programs to store then. And they were more expensive than the 90 minutes ones. Guess what I got? And the most important feature was actually the tape counter. So you would write down on your cassette envelope 15, 23, and then put the name of the game or your program that you wrote next to it to figure out how to find that. The problem is if you had a 90-minute tapes, they were very thin. So what happened from time to time that actually the tape recorder ate the tape. What a pity. With music, you could actually squeeze it again and it might still work with some like a wobbly LP. LPs get vinyl gets popular again, so some people might know that. Just put it in sunshine and see how it sounds. That's like a cassette tape sounds after it had a problem with the mechanics. And so it was really a pity if you lost your 90-minute cassette full of games. And even worse if it was your program that you wrote for handing it in at the university. And I could do that on my Sinclair Spectrum. I had a Pascal compiler, and first lecture was more or less Pascal programming. And when I started the university, after I got that computer, it helped me a lot. And just to consider if you, it's hard for me to see who is female here, but there are very few only. When I started university, there were about first year students, and 400 of them, and 25% of them were female, which is a pity. When I started to become a professor, we had about 100 first-year students, and if we get more than one female, it was a celebration already, and it still is. So getting girls into computer science or software engineering is really something we need to work about, because they make so good, women make so good team partners in a software engineering team. Now, to solve my programming lessons and hand them in, we had to hand in the programs on paper. And I got a little printer that was actually printing on silver paper, like some of the old cash, how do you say that? Cash registers. Who has used such a printer or has seen one in this life? Okay, who remembers the smell they make? That's a unique experience. Ask those guys who raised their hand to know that. But actually, the paper was really brittle, and you actually had to photocopy it, the silver print, on a regular A4 to actually hand it in so the assistants could grade what you did. And another thing is, the Spectrum helped me a lot because I could use it whenever I wanted. With 400 students in the first year, we had to line up for the terminal room to get a seat at a terminal. And sometimes after half an hour or so, you had to switch to someone else. That's when I learned pair programming on a UNIVAC 1100, which is a very interesting computer. It had a very interesting assembly instruction capability. You could have indirect addresses, like putting 2 stars on a pointer by a specific bit in the word. So when that bit was set, the word wasn't interpreted as the value, but as an address to look up. So automatic indirection, so automatic star and C pointers. And if you put that at that target address, again, that indirection bit, it would redirect to somewhere else, and that could go endlessly. So once we learned about that bit, the first thing that a colleague and me did was write a single instruction assembly program using a load with the indirect bit set with the same address of the load itself. It was a very tiny, very endless loop on the mainframe, which only was interrupted with hardware watchdog because it didn't support mid-instruction interrupts. After we started that program for 2 times, it was killed after a 2-second watchdog reset. The ops personnel, the assistant from the math department, came running into the terminal room and almost shouting out who was running, who has that user ID, some cryptic number. And we raised our hand, and I said, "You're very clever guys. Don't ever run that program again." So, nevertheless, the UNIVAC and its Pascal compiler was really impressive because one typical thing is you learn recursion, so you implement the 8 queens problem and figure out all the solutions, how to place 8 queens on a checkboard. And my Sinclair Spectrum took about 2 minutes to compute all the valid positions. And on the mainframe, it was just press transmit, and the result was there, which was really impressive. Okay, it's something bigger and faster than my small computer with the rubber keys. What did I learn? Oh, that's my second car. Actually, it's not a picture of my car, but a picture of a car with the same color and make. That was the times when you didn't have these cameras everywhere, and making a photograph was about 1 mark to have it developed. Today it compares to €1 or maybe 50 cents. So it was quite expensive to shoot photos, and I'm still, I was shooting a lot of photos, but I couldn't find a picture of my car. But I learned BASIC and Z80 assembly, machine code, and Pascal. I learned about keyboard shortcuts and meta layouts. I learned about patience. Loading a 48 kilobytes of RAM with the next adventure game was really patience, especially if it broke off after halfway through. And I learned to deal with errors of the hardware. After 2 years of university, or at least 1.5 years, in the break time, I started my first programming job. Fortunately, 2 of my older semester colleagues actually had founded a company for doing programs, and they asked me if I would join them for working for them, programming for them, and that's what I did. I learned a lot because putting code into practice and doing software that actually people had to use was a big difference from the exercises that we could do at the university at that time. One thing was, okay, the cat has to be able to run over the keyboard and the program mustn't crash, which was quite challenging at the time using DOS. And I wonder if you can still do that on modern computers. I dare not to try that on my laptop right now. I used to program on an Apple II. I didn't own one, but the company had one. And one of the things they did, or most of the things they did, were address management, customer addresses, customer records, sometimes other stuff. It's more like what you would today use a database for and say, okay, it's more or less a CRUD application, create, read, update, delete thing. Nevertheless, at that time, not many, let's say, database systems were available or actually working. They used to, so for the Apple, you also didn't have a hard disk, so you had floppies, fortunately 2 of them, floppy drives. So one thing that I implemented with the Apple IIe was customer record keeping for some company there, and they had more customer records than fit on one single diskette. That's a bit of a problem. So and they wanted to print lists and whatever mailings from their customer database. So what I did was, and those should be sorted by some kind of alphabetical system. So what I implemented was a sorting across multiple diskettes of their customer records, which was interesting. You had to program the operator to insert the right disk at the right time at the right drive, and maybe not, and figure out if it's right or not. And to sort stable over a large thing, I learned in theory, okay, there's merge sort to do that. Who has implemented merge sort or used it? Or learned about it in school still? It's kind of okayish. So one book that we used was Niklaus Wirth's Algorithms and Data Structures equals Programs, or in German, Algorithmen und Datenstrukturen. And I took the code from that book, typed it into my Pascal compiler on the Apple, made it work with the diskettes, and figured out, okay, sorting as it's supposed to be in the merge sort is stable. So if you sort by last name and then by first name, or the other way around, it should remain stable, so the names come out right. It turned out it wasn't stable, the implementation that I just typed in. So I had better understand what the code was about and port it, and I figured out, okay, the implementation I took from Niklaus Wirth's book was for arrays, and he didn't dare to make it stable. And it had bugs in it as well. So I got back to the theory, implemented merge sort as it should be, and made it stable again, and not copied code from the thing. The next thing after the Apple, what they got was a Victor Series 1, which was a kind of good PC. It was more powerful than the IBM PC, had a much better graphics. I remember playing Snake on it for nights in a row, and programming it. And the Victor Series 1, or Victor 9000 Series 1, we had actually a hard disk drive. That were the times of DOS 1.25. Who of you has used DOS 1 point something? The big limitation was DOS 1 point something didn't have directories. So to actually make use of a 10 megabyte hard disk was to put 10 partitions on it, each 1 megabyte, which was 3 times the size of a single diskette capacity. So you could actually, and you had to remember, oh, C is for the operating system, D is for your data, and E is for your program, and on F you have your compiler and stuff like that. Among other things, after the Series 1, I also used a thing that was called Apricot. It's actually the continuing company, the Apricot PC. I even had it for taking home, so I could work from home with it. It was quite cool, the Apricot computer, but all the fruity things were replaced more or less by the IBM PC. And I can actually claim I worked on one of the original IBM PCs, not the XT PCs, which looked exactly like that with the 2 floppy drives, which one was later replaced by a 20 megabyte hard disk drive, which cost about as much as the whole computer in addition. And it had a splendid 512 kilobytes. Let's see if I can scroll my notes. Okay. After the disaster with the sorting and the cross-diskette sorting of the custom records, my bosses said, okay, maybe we better use a database program. At that time, that meant DBase 2 or DataFlex. DBase 2 was horrendously slow. DataFlex was fast and quite good, so I liked it a lot. And I believe it's still available somehow and somewhere. I have no idea what state it is in. But they also continued to program stuff in Pascal, and Pascal at that time had the problem it didn't have proper strings. So each string actually had a fixed length, like it is in C. And if you, and then they had address database with strings, and okay, what do? Yeah, you make the street name length 32 characters, and then you get some streets that get very long names, and your clients say, oh no, our customer address wouldn't fit into that field. Can you make it longer? So they had to change this 32 everywhere in the program, because you have to check that the input is correct and fits into the strings. And that's when they came up, okay, we need to do something better and do it our own. In addition, they used an indexing library written in assembly that was just broken. It worked most of the time, but only for a week or so when it messed up its index, so you had to re-index all your data to get actually a working search. So I implemented B+3. I'm not sure if I can, yeah. That is how it looks. If you ever want to do that your own, don't use whatever you get from your database system. But it worked quite well. And they continued to be successful with that. And one of the colleagues actually wrote a screen editor, so we could actually draw a screen on the 8025 IBM PC, mark input fields, and get a database system for that screen automatically generated by data-driven program. So the program read in a specification file with the screens, and then you had your CRUD application for your address management, which was quite an improvement to program everything by hand, each thing in Pascal for each customer. From the money I made, I bought my PC clone, so just without that label, with 640 KB and 2 floppy drives. And color graphics, because I wanted to play game. Unfortunately, I didn't have a color monitor. So it was figuring out which pattern was actually reddish and greenish, just because either way. Another thing that my PC actually lived throughout my university time, and it even got upgraded to become a 386 with an Intel inboard. I'm sure nobody has heard of that. Where you can actually plug into your 8080 slot a cable and plug in an extension board with the 386, 32 bits. Wow, 16 megahertz, even better. And it was fast. Some of the games you could no longer play because they were too fast. You died immediately. And it helped a lot compiling my diploma thesis. On that 386, I started out doing using the Minix operating system, which was written for the PC, so it used 640K, and I had now 3 megabytes. What to do with all that amount of memory? So I wrote a RAM disk driver using the special memory management unit of the 8386. So I had a RAM disk for my compiles, which speeded up even more. The thing is, I stopped then with the 386 special memory registered. Linus Torvalds continued from that and created based on Linux. So maybe the big difference is, first I had a girlfriend. Second, we don't have nights that last 6 months in Germany. Another thing that I used at that company on the PC was a very decent editor that supported macros. It was called PMate. And that's an ad that I found on the internet on that PMate editor. And the thing is, most program editors are shocking primitive. And that sentence rings a bell. Who is using Vim or VI for programming? Who is using Emacs? Who is using a decent IDE like CLion or Visual Studio or Cvelop or Eclipse? Who is using neither? Let's stop like that. PMate had macros, and it came with a nice set of macros, like when you press if blank, it would generate an if statement in the language you selected for you. Or while, and it would generate a while statement for you. So you didn't have to type every character of your program. And that made us much more productive than typing everything. It was close to the Syncler where you press a single key and had print. But it was even better because you get more structure from it. So that's an important thing I learned. Plain editors are too weak to actually be useful. So PMate, extinct today, but again, having good support for fast searches, fast typing, handling multiple files in your project, that was an important thing to go for. Lessons learned. Do not trust programming books or commercial libraries. Test against them, even if they're used or sold quite often. When putting your own code into a book, take it from a running system. When I prepare my lecture slides, I always take code directly copied from the IDE because I know it's correct. I sometimes regret when I fiddle it for layout and break it. Programming should be supported by a fast and powerful editor, and have a very specific opinion about editors versus IDEs. Those who still program with Vim doing it wrong. I only use VI for very short 5-line shell script or something like that. You should not need to type in all of your code because it's structured, it's a language behind that, it's very easy to generate for you. And I learned to automate tests. Oh, I didn't tell you the story about the B+ tree implementation. I did that in Pascal, and it's a tree, so you have to search, you have to remember the path through the tree, so I used the stack for that. And I didn't want to make that dynamic because that would be slow and searching is happening quite often, so I made it a depth 10, which is quite, gets you a big tree if the nodes aren't too small. And they were allowed about one disk block then, 512 bytes big. And we figured out, okay, 10 is a tree that gets to depth 10 as a B+ tree would mean far beyond the available hardware then. So we wrote a test case against that to see if it will work with just more than one node. And somehow after a couple of hours, that test case crashed. And it crashed because we made the nodes deliberately very small, I believe 16 or 32 bytes. So only 2 elements would fit in the node instead of the 10 or so that would fit, or even more, that would otherwise fit. And the tree got deeper than my stack of 10. Which was good because it worked very well throughout, and we figured out, okay, we can reach its limit, and we should do something about it, but we will never reach it on the available hardware then. Today it's a different story, but that code is extinct, it's no longer useful. So automate tests is a very good thing that I learned then. And it was well before unit testing became popular. After some programming experience, and in Germany at the time, you had kind of a mid-study time graduation, the so-called Vordiplom, and I was entitled to work as a tutor within the university, and from that tutoring work, I learned how to teach, more or less, and I was hired by a training company. It's still in existence, it's called Freund und Dirks. That's their new logo, that's what I still have on some of the folders that I used for the training. And that company had one major customer. It was the biggest computer company at that time in Germany, Nixdorf Computer. Who remembers Nixdorf? Some of you. Only the old people remember that. Nixdorf got extinct in 1990 when they merged with a very bad performing company in trouble, merged with a very bad performing part of Siemens to become Siemens Nixdorf, and then the managers wondered why it wouldn't fly off. The synergy at work didn't work that well. But Nixdorf Computer in the mid-80s or early 80s, they made a strategic switch from their proprietary basic mid-range computers were for business application to Unix. Somehow some geek convinced them Unix is the way to go. So they changed all their hardware to run on Unix, multi-user, multiple terminals, very nice terminals they had, orange. But they had to train all their personnel because it was strategic. Even secretaries had to learn how to use Unix because that's what they got on their desk. They were eating their own dog food. So we trained Nixdorf people not only in C programming and Unix system usage, but also in using VI. So I still have VI wired to my small brain, at least some of the basic commands. We trained them in using regular expression, awk, SED. Was that my mic? Better? Yeah. So we trained Nixdorf employees from everything from using the shell and ls and using directories, to C, Unix systems programming, compiler construction using Lex and Yacc and everything. That's not me. I learned a lot teaching C programming to others, especially to programmers who knew how to program in other languages. This is off. So, but I learned, especially having Fortran or COBOL programmers in the C course was a very interesting experience. I learned to teach them how to unlearn stuff that they used to do. I have no idea what to do about that. Maybe that is a problem. Okay, let's see if we can continue. So, that doesn't work as well. In addition to Nixdorf, we also taught Unix for IBM. Let's try with the dealing with hardware failure. So for IBM, we did actually I developed a training course for people that need to learn to program because their job was going extinct, and that was something IBM cared about then. It's not just laying off people, no, we retrained them to return personnel and keep it in the company. That's an ethics that got lost with all the Sarbanes-Oxley and stuff like that, and all the consultants. But what I trained them on, we had a Fischer Technic model factory and was programming them to move stuff around. So I did some robotics then. And I learned about layering my system, so to actually have layers of abstraction, and we will try that other hardware again and see if that layer works now. Hope so. So, better again. Okay, always bring your batteries. So, yeah, that Fischer Technic model factory was quite interesting. They still sell something like that. It was a size a little bit bigger than one of these tables with a large warehouse simulation and some conveyor belts and robots moving pieces around. It was a fun thing to work with, especially to figure out how to teach people to program with that. And I also had to debug the hardware because we had a separate hardware company that plugged in driver, built a box with drivers to actually control the engines. It's not like the Lego Mindstorms that you get today where everything is built in and just plug and play. And yeah, that was a fun thing to do. We also used some guidelines that we taught then, like a function is too long if it doesn't fit your terminal screen. I visited Google in Zurich once, a couple of years ago, when they still wasn't their initial offices. I've seen people using two 30-inch monitors, one vertical and one horizontal. And the vertical one had Emacs or VI open with code listing, and the function didn't fit that vertical screen. That tells a lot about the mental abilities of the programmer working on that code, but it taught because you have to have a very big head to actually figure out what's going on. but also it tells you a lot about of the software engineering problems Google is facing internally. So that 80 by 24, I would say today 24 lines is already very, very long for a C++ function. At least for the body. Another thing that I learned was a function should not take more than 3 to 5 parameters. And if it's more than 3, consider putting things together in a struct and pass that struct. When I have seen the Windows 1.0 API, which is still very similar to the systems API of Windows today, I said, I will never program to that operating system because I cannot deal with 7 or 8 parameters where at least half of them are null in all the examples and you never know which one is which. And one thing at that time, we had Kernighan and Ritchie C, so everything was an int if you not specify that, unless it's a pointer or a double. So that everything is an int is a curse that still hits us in C++ templates because we still have to use type name. The reason we have to use type name in some template context to specify that a dependent name is a type name is that legacy from C that everything is an int. So if you use a name without any knowledge, the compiler assumes it's an int. That's the reason why you have to use type name. I also learned how to apply my theory of abstract data types in C by using opaque structs and pointers, and that worked quite well. And I also learned don't use scanf in production code. Who has ever made a mistake using scanf? Never ever. Who has never used scanf? Okay, good. Even as scanf, you better check the output value to figure out if it went well or wrong. The courses, just to show you some maps, these are roughly the locations where I was teaching in Germany. Nixdorf's main seat was in Paderborn, and recognized Germany was still separated then. And the Berlin map is wrong because it includes East Berlin. But Paderborn, I was told, it's in the middle of nowhere, and it actually is in the middle of nowhere. I hope nobody, so if you ever want to find Paderborn, I learned a story from one of my colleagues is, okay, mark all major cities in Germany that you know of, mark all major tourist attractions in Germany, mark all autobahns that you know of, and then you have a large wide area in the middle, and that's where Paderborn is in the center. And we had Mainz, Ludwigshafen. I taught a course at BASF, and IBM and HP in Sindelfingen. The highlight for me was actually a 3-week C systems programming course in Singapore that I was teaching to Nixdorf Singapore employees, and you will not recognize these people, but I think that's me there. And so that was a highlight. I learned how to teach in English without early experience. All of my textbooks were in English, but teaching in English was quite a challenge. I learned about hot and spicy Asian food and love it since. And it was really a lot of fun there, and 6 days of training per week for 3 weeks was quite intensive. What did I, oh, and I got a red car from the money I made from teaching, a red Ford Escort with a little bit more power. I learned Kernighan and Ritchie C, Unix, Shell, Awk, SED, and I learned to love them. SED, Androff. We used Androff to make our slides, which were actually plotted on a plotter with a pen, and were actually slides that you could take out and put on an overhead projector like that over there. I learned that I learn most by teaching a subject I care about. So if you have to teach something, you learn. I learned C at that time, especially Kernighan and Ritchie C, to a depth I would never have been able to learn it because I needed to explain all the mistakes my students made, to tell them first how it's done right, and why their solution is wrong, because it might be undefined behavior or just plain wrong, access memory that you're not allowed to, so you get, at least on Unix, you most of the time get a segmentation violation, so it actually breaks your program. I also learned how to deal with program code written in a foreign language in C, and tell them that it's not a good idea in COBOL to actually define 100 global variables before you start main, just in case you might need them. I learned about abstraction, about layering, about cohesion. A function should do one thing well. And I learned the power of plain text, as the pragmatic programmers put it. Dealing with plain text, like grabbing a file, using regular expressions powerful to change, replace stuff with SED or awk, or figuring out from a log file what went wrong when. That's where plain text is powerful. Who is using Vim or something similar to search log files today? A few. Who is using a log file managing tool? Few. Who's using Perl for it? You know, Perl was invented to actually grab log files and do something about it. And just because the author didn't know awk well enough. So pipeline scripting is stuff that I learned that I still use. I can still impress some of our ops people by my tar skills, copying directories with permissions from one machine to the other in a pipeline. In 1989, I finally graduated from university with a diploma thesis where I wrote a compiler for the Amsterdamer compiler kit. And I also did the first experiments in C++ with Sortex C++, because of my C background, C++ came naturally. Once I got a compiler, I tried that. The Modular 2 compiler was running on the university's 68K20 Unix computer, and I even managed to crash that with my compiler. Again, very similar thing to the Univex story. The system couldn't handle mid-instruction page faults, and it was one of the early computers having actually paging in Unix, not only swapping. And if you didn't care about generating code that didn't have an instruction crossing a page boundary, which the system compiler did, it would just crash if you're unlucky enough. And it was rare enough. And the whole kernel would crash. It's not just your program would just die, the machine would die. Which is you make very good friends to your fellow students if you crash their machine where they are working on their thesis at the moment without knowing what's going wrong. So after several tries of doing that, I switched back to swapping and just disabled paging for my generated binaries. That was a time before the GNU compilers were available, but again, I didn't want to crash the system at the university too often, so I worked a lot on my PC with Minix and PC-DOS, and I ported a lot of the Unix sources of the tools like make or grep or awk or SED to my PC-DOS machine to be able to actually have my make files work the same on my PC as on my Unix environment I worked on. And one thing was Microsoft's NMake at that time just didn't make it. So porting skills were called for. I ported also Lex and Yak, as you have seen here, Lex and Yak for generating my compiler. I wrote the Modular 2 compiler. Oh, it's not me, okay. So I wrote the Modular 2 compiler in C because that was a language I was much more familiar with, even though I learned Modular 2 and I liked it much more. I've seen the sources of Niklaus Wirth's Modular 2 compilers and I dared, no, I don't want to write code like that. I also was in desperate need of what we get in 17, variant. I used the discriminated union type in my C code for the compiler for having the AST node or the type nodes. I'm not sure which class, which struct that is. I think that's about the things that the language cares about, the symbol table element. So Even I didn't know that variant would exist in the future, I had a use case for it. Lessons learned. Well, compilers are fun, ASTs work, and polymorphism even works in C if you employ unions. I learned a lot about virtual machine language. P-code, the Amsterdam compiler could use the variant of P-code that is called EM code. And if you look at the JVM definitions or CLR, it's not that unfamiliar if you know EM code to see the JVM code. I would say 80% of the semantics of the language statements are identical. RAM and processing power helps, so my Intel 8386 with 3 megabytes was really a powerhouse for my compiling. It went down from 2 hours compiles to 20 minutes, full compiles, which was a great improvement. That's why I wanted to make to work, because you usually wouldn't edit everything and have to recompile everything. That's why I learned Make quite well at that time. And Lex and Yak can actually be used in practice. Compiler theory is not only theory. That was also important for me. And I'm still a compiler kind of guy. After university, I was drafted. Oh, shit. I skipped the draft at the age of 18. But the German Bundeswehr was very eager to get more soldiers because they were running out of the strong years. 64, when I was born, was the strongest the highest birth rate in Germany. And then it declined, the so-called Pillenknick, which is and so I was drafted after finishing university. I knew about that, and I also learned, oh, they want to extend the period that you have to serve from 15 months to 18. I tried to be drafted before that 18-month time kicked in, so I applied even before I was completely finished with all my exams. Unfortunately, I was drafted for 18 months. The good thing, from my boss at the training company, Dirk Dirks, who was an officer at the programming center of the Air Force, Programmierzentrum der Luftwaffe in Germany, I learned, okay, there are some interesting jobs for computer science graduates at the Bundeswehr. I moved there. I applied for the programming center, and after 3 months of actually learning how to shoot at airplanes with a little gun, or with the rifle, which wasn't very successful. Even if you had 50 recruits shooting at a model airplane, we might have 1 or 2 hits of them. And they told us, well, you could have taken down that fighter jet. I doubt. But after learning to shoot and a lot of some hiking, I entered the programming center, and I was one of the better educated persons there. Because either you had some older officers that more or less had a training on the job, and some very freshmen from the University of the Bundeswehr who were similarly educated but with much less practice than I had. So what happened in addition was 1989. Some of you might remember we had the East German Revolution. So we were heading towards reunification in 1990. And that actually made me, serving as a conscript, the last one who actually had to take a 15-month run as a conscript. Because later on it was reduced to 12, 9, and now it's extinct. If I wouldn't have applied to get a job at that programming center, I would actually never have served at all if I would just stayed a little bit longer at the university and kept my head down. So, but I don't regret that because I learned a lot. The work at the programming center for me was like getting into a time machine and having a time travel backwards. Not only this nice colored black and white shot, but I also I learned to work on an 18-bit computer, and that's the only image I could find on the internet for that. The programming center were developing software for radar systems and maintaining that. And that was a US aircraft 18-bit computer coming with two 16-bit front-end processors and tape drives and tape machines. So I learned to operate that, and if you look very closely, there's a little row of switches here where you could actually enter bits individually into memory. And it had core memory, which was kind of magnetic rings with wires through it. And because you wouldn't want to program with these bit flips, except for the bootloader, we also had a PDP-11 with tape drives. So the PDP-11 was the main computer for them, where they edited and kept the source code, wrote tapes to be put on the US aircraft machine. You load the source code tape, the operating system tape, the compiler tape, one after the other, in some magic sequence, and the printout tape, and then you figure out, okay, something went wrong. That's why I wrote a tool that ran on the Unix machines. They had the PDP-11 and the HP UX machines to check the syntax first. It was a great productivity improvement. And with my Lex and Yak skills, it wasn't a big deal. And we also used that. Who has seen a thing like that? Who has ever heard VT100? You might are using ANSI escape code. The VT100 terminal is the original thing that more or less defined what these ANSI escape codes mean. And because they are so cool, and in the ops center, we actually had a 9.6 kbit line to the PDP-11. We wrote Tetris using escape codes on the VT100, and it worked quite well. You couldn't play it in the offices because they only had a 1200-bit line that was scrambled and too slow and multiplex. So but we could play it in the ops center, the drafted soldiers. And today, VT100 is still and that is a language manual that I use to write my syntax checker. The language is called Jovial. It's a kind of Pascalish, Algolish language, and there's a nice story about Jovial. It used to be called Ovial, and then some strange algorithmic language, and then they nicknamed it after the second name of the main author to become Joule's own version of some algorithmic language, and that was Jovial. It was a long time in use in the military before Ada came around and was made popular enough. In addition to my programming and my ops tasks, I also trained the officers in C and Unix because of their lack of knowledge about that, and that's where I could actually I had to redevelop training material for the Bundeswehr, but I used all my knowledge about C and Unix that I had from the training companies. And oh, by the way, that was a disk drive of the PDP-11, the size of a washing machine. And you better not have a hack crash. And that was the console. That is actually a console of the PDP-11. And if you press Control-S, the machine would stop. And if you press Control-Q, it would continue again. So you could actually make everybody take a break by pressing a single key on that console in the ops center. Oh, and that I learned, okay, ice on the Autobahn on January 2nd on the way to the service was a bit slippery. I had a big crash. I was very lucky that I didn't hit anything hard. The only thing that stopped me was some bushes on the side, and I more or less got my car parked on the parking slot that was just after a bridge, so I didn't hit the bridge. So I'm still here. And when I stepped out of that car, I was unhurt, but I almost broke my back by slipping off from the ice on the outside and falling on my back. So I managed to not break any kind of limb, but I survived quite well. But I had a broken car now, so I need to get a new one because I need to actually get to the Bundeswehr Kaserne, which was about 60, 80 kilometers away. But I had saved some money from the training courses, doing the teaching, so I got my first BMW 320i, and that's where the BMW career started in 1990, January 1990. So that's the car. The lessons I learned from the Bundeswehr, the real one, computer and software history can be interesting, and sometimes time machines are really interesting. And even hardware, not only software, can be used far beyond its expected lifetime. And source control is important. So I learned SCCS and all the problems it has. But I learned source control is important. And copying your thesis to a floppy disk is not source control. In 1990, I went there, nicknamed Legoland in Munich, which is a Siemens campus in Neuperlach. And I applied for a job where it was about creating a programming environment for object-oriented programming, nicknamed OPU. It was intended to be written in C++, for C++. We had a prototype based on Eric Gamma and Andre Weinand's ET++ application framework. And that was the job I actually applied for. I had other offers doing more also about compiler stuff, and then I asked that company ST&M, you might also know that, a very big German company, and I said, I will never program in COBOL. That's an oath I've sworn to myself, because I've seen how COBOL programmers program C, and I don't want to get there. I failed. I was successful not getting the job at ST&M because they couldn't promise me not to force me to program in COBOL. So I went to Siemens for 1,000 marks less per month, but I learned much more at Siemens. Because the OPU project wasn't funded right from the start, we sidetracked on doing some other programming environment tooling. It's an object inspector for a C-based, C macro-based OO language called Torus Ober. And by the way, Torus Ober was then used on BMW's diagnostics computers. So if you, in the 90s, drove your BMW to your garage, it got hooked to a computer running that system, or programmed in that system, which had its problem. That's why we implemented the Ober Inspector. And after we've done the Ober Inspector and initial work on the OPU, the project was killed due to internal politics, because a programming environment would serve more than one Siemens business unit. And the medical department wouldn't want to pay the automation something or vice versa, and they fought against who will fund it. Oh no, we won't fund what you benefit from. So accounting models can actually kill innovation. A couple of years later, some other guys used ET++ to create a product that was a great idea that I used later on, called Sniff+. Anybody knows Sniff+? No. Okay, it's more or less extinct. It was acquired by Wind River, then Wind River was acquired by someone else. So in some embedded domains, people might still have used Sniff+ well into the 0s years, and now everybody uses Eclipse CDT, who came from that area. My first architecture, the Ober Inspector, looked a bit like that. It had a graphical user interface. You could actually unfold objects and relations and map the attributes of an object and see the relations. And to do that, you had the application process with a small stub that was able to communicate with another process that actually ran the UI, because if this one had a UI, you couldn't plug it in the same UI, so I had a separate process with a separate UI. And even though I was brand new at Siemens research. I was the only guy who could actually program from the researchers there and had the Unix experience to set up, okay, we are doing it like that with a pipeline in between, and that's how it can be done and work because of the constraints of the environment. And I was very proud of myself, and they actually worked, and people used to improve the Torus Ober software with that. And that was well before the data display debugger was invented by, what's his name? Forget it. And learning C++ and seeing what bad things you can do in C++ in 1991, we published, I was a co-author, C++ guidelines. Some of the rules still apply, unfortunately it's German. Some of them are obsolete, like, okay, rules that still apply might be, okay, a virtual destructor if you have an inheritance hierarchy in the base class. And a lot of things, or some of the things I learned how to do better today, first because C++ evolved. That was well before standardization. We didn't have exceptions, or at least working exceptions. We didn't have templates, or at least working templates. In 1991, we had CFront, which compiled C++ code to C, and then considered the debugging of the generated C code, which was a nightmare. That where guidelines help. And it's also very easy to crash CFront. So crashing machines, crashing compilers is one of my things that I learned. In 1991, I got married, also in a BMW. And later on, after the OPU was killed, I started to work on patterns. Why? Because my colleague Frank Buschmann was inspired by the work of Eric Gamma before the Gang of Forbutt came out, and we started writing architectural patterns. That image shows me with the Gang of Four, Richard Helm, Ralph Johnson, me, then it's John Flizidis, the late one, and Eric Gamma. And I joined that Architectural Patterns Collection project, and so we became a party of 5. 4 of them are here, Frank, Hans, Regina, and me. And missing is Michael Stahl. He wasn't there at the time, or maybe taking the picture. And you see, I already had gray hair, at least. I stopped dyeing my hair after I got married. Working on writing up the experience in patterns was really where I learned a lot. I understood a lot about architecture. I understood a lot about design by trying to explain it and explain why it's good or bad. In addition, we were very grateful to Jim Copleen. That was a later picture, so I already lost my hair, but that's another story. We were very grateful for Jim Copleen, who taught us how to spell out patterns, forces that make the pattern hard, and that actually led to what then was nicknamed the POSA pattern format. And in 1995, when POSA 1 was released, we had that. We celebrated the release of pattern-oriented software architecture, a system of patterns, which is now nicknamed POSA 1. Who has seen POSA 1? I asked who has a book with my name on the front. Okay, some of you. If you don't, get it. Considering design patterns, who has got this book? Good. The most important patterns, most of them are about programming against abstraction and having specializations by inheritance or other means. I would say the most important things is command, which we now have as lambdas available readily. Strategy. Strategy was the design pattern where I learned how to use virtual. Over there. Template method, always usually combined with factory method. Composite, which is also most important. Maybe decorator and null object, especially in the combination with strategy and composite. And those are the most important ones. The most spoken about pattern is the one that I dare that you don't use. And there's a story behind that. Singleton was invented to cure a problem. C++ doesn't have a defined sequence of global initialization. And if you have, but you have constructors that can have interesting side effects. So if you have a constructor that has an interesting side effect and have multiple compilation units, especially across dynamic link libraries or shared objects in the Unix terminology, you easily get into trouble by using something that is not yet initialized. Which is something, it might actually be initialized depending on the sequence of the object files that you pass to your linker, which is a very, very strange and interesting thing, and you get very hard to debug stuff because it happens just before main starts. So even before your first breakpoint hits, your program crashes, which is not very nice. And that was the reason why Singleton was invented, because all the initialization was made runtime dynamically, and you had globals that you could actually access globally. Don't. Just don't. Think about design first. That's part of a slide that I show. Okay, don't use it. Don't use Singleton. I say it again, kill it. And I told that story again already. One nice thing about the patterns is that there was a community formed around it in the PLOP conferences, and even more long-term is EuroPLOP. EuroPLOP is, I believe, in the 23rd year now, happening next month in the same location ever since, and that's the location. And EuroPLOP and the PLOP conferences are all about knowledge sharing, learning from each other, and creating a safe environment to think about crazy ideas. And also meet people. One big thing is that PLOP conferences usually come with a game facilitator, and I know at least for EuroPLOP it was the same for 20 years, George. He's an art therapist and a very great interactive people-oriented games designer or facilitator. And I met so many bright people I still consider friends today at the EuroPLOP and PLOP conferences. And also the conferences are completely atypical. It's not like someone standing here and giving nice speeches, but it's about discussing in workshop format or in circles about stuff that has been written and should be improved. So it's all about improvement. And the process even starts before the conference by having a shepherd assigned. So you can start up with a rough idea of a pattern and then get a shepherd to help you to better formulate, become a better author, a better writer, to share the knowledge of how to write good patterns and also about the stuff that's in the pattern. That's important. And this is a broken parachute that is actually used to play together and getting people to form a team. Let's see if I can click through. Some of the people I met in the front, that's Linda Rising, and I think I made her try at least the only schnapps in her life. Couple of others, Siemens folks, Hans Ronert, Linda again, and I cannot recognize. That's Markus Völter and Uwe Stoon. That is also like things I'll be playing with a big ball and people having fun. Other people I met at PLOPs like Brian Foote, Rebecca Westbrook, and Andrew Black, and Dick Gabriel, Kyle Brown, Rebecca again, and Bobby Wolf, who some people might know from some kind of pattern books, enterprise integration patterns and enterprise architectural patterns. Ralph Johnson, James Noble, Joe Yoder and Linda again, and that's POSA 1 and C. We have actually 2 covers for the same book, and the big difference is we got a prize. And a map. The second book has a better layout. We have a back cover with a map of the patterns. And I would say one of the most important patterns in understanding in that book is layers. Who of you has implemented a layered architecture? Who has implemented a tiered architecture? Multi-tier. This is a big difference that I regret we didn't put in the book well enough. If you have a layered architecture, you layer about levels of abstraction, and you can easily exchange an individual layer. Like I exchanged my Unix operating system with PC-DOS on the layer label, and still kept the tool and the code working. A tiered architecture, one application concept typically stretches all tiers from database to UI. And what happens is the other thing, like, oh, I changed the address record layout, so I have to change it in the database, in the business logic, and in the UI. And maybe I have multiple UIs as well, like for the phone and the Fat desktop. So changes are not local, and you actually have to master all technology levels if you work on a tiered architecture. It's not bad, it's just completely different from the benefits that you might get from a layered architecture. And one of the reasons of that layered architecture is that you can actually split your teams across expertise. And here you split your team across concepts, but every team has to do everything, or you have a large communication overhead, so you actually, if you have a database specialist communicating with the UI specialist to actually figure out what to change. And that's an understanding that's often misled by people thinking tiers are layers. And we did that as well, I confess. So think about that. Good abstraction is a skill. At a university, we had a system written in Modular 2, a database system, that used about 7 or 8 layers, but most of the layers were just passing through and not giving you abstractions, and that's also a big problem. Too many layers without having a clear understanding what the level of abstraction you have is a problem. So get your layers right. And we got a convertible in 1992. Exactly before they switched the model to the rounded one that was really ugly. So that, and we had that for 8 years. What I learned from the book experience with POSA 1, a prophet has no honor in his own country. So you need to get out to get heard in a large organization. Good patterns require several rewrites. The POSA book patterns were written at least 4 to 5 times, completely rewritten. Shepherding teaches you to become a better author, which helps me a lot with my students, which I shepherd throughout their thesis project, and I always urge them to start early with documentation because then I can improve their English and their writing style. And whenever you publish a book, get a good copy editor. Even if you know how to write well, there are people who will actually fix your language for you. A network to learn, attend and speak at conferences or run conferences. And the most important things at the conferences are the breaks. And we are not yet running into it. I still have 20 minutes or so. I hope so. Yeah. Now he's getting his time sheet. And you've written that wrong. It says 10 minutes. The actual using Stützchrono is 10M. And I'm guilty of that suffix. In 1997, I applied the Hollywood principle. Don't call us, we call you. I called Eric Gamma because I was fed up with Siemens corporate politics and not getting a raise. I called Eric, I would like to work with you. And he said, oh, I will call you back. And he actually did, not like a Hollywood producer. And he told me, well, I cannot offer you a job, but you can have my job. That was a time when he founded the lab that later became the lab that created Eclipse, among other things. And I took over the remains of his team in a small company then named IFA Informatik. We bought that company from the owner, which was one of the big Swiss banks, and renamed it Itopia. And I took also over a small framework for server application. That was a time when Java just wasn't ready to run server software. And it's still available open source now as Coast, coastproject.org. It's ancient C++, so don't expect C++ 17 code in there. But it's still in operational use applications written with that framework. And I still have a maintenance contract for that framework from the university. In that era, I learned about server applications, much more than I used to know about that. I learned about unit testing. I got test infected by Kent Beck and Eric Gamma in 1998, I believe, when they, or maybe, yeah, 1998. We created that framework, and the problem was with the framework that is used in different applications, you get in a tie-in, either you cannot change the framework because you have to upgrade the applications, or you cannot upgrade the applications because the framework changes too fast. And if you invent bugs by moving forward, it's a big problem. So I got test infected, and we consciously wrote unit tests for the application framework on all the code we did. We delivered high quality solutions, and the high quality showed off because one solution that was intended to run for 2 years just to cross the year to K problem is still in operation today. Slightly changed and evolved, but it's still in operation. It was meant to run for 2 years, and it's almost 20 now. High quality gives you better developers because they get more satisfaction from their work. It even helps not so good developers to become better developers because they learn from that. And you can retain good developers by high quality software. But there's a commercial side effect from high quality software that I didn't know about. It led actually to the point where our customers canceled the maintenance contracts because they just didn't need them. And what also happens, a competitor who also served one of the clients was actually almost every week escalated to the board of our common customer because of problems with their software. But instead of kicking out that company from their purchasing part, that company with the bad software actually learned much more about new projects than I did because I wasn't visible to the top management because our software just worked. So I stayed down in the lower techie levels and not knowing about where the budget would go next year, which was also bad for business. And one thing with the tests, and again with the global initialization, that's an example from Google Test, but we created our own testing framework even then after we started testing, is that a simple macro, first it changes the syntax, and then it expands to a lot of code that you don't see in your source code, and the global initialization. And if you share your tests and code across DLLs, you get into that problem that you might use stuff that's not initialized yet. And that's not where you want to be in C++. That is why I created later on the Qt testing framework for our develop that has deliberately runtime test registration that is generated for you from the IDE instead of these macro-ish things. So don't use Google Test. It's not good. Lessons learned. So that was a convertible when we sold it. To advance technology-wise and personally, you have to take risks. It was a big risk for me. My wife was still working in Munich. We were not sure if she would get a job in Zurich or in Switzerland. She got a job, and now she has a much better job than I will ever be able to get. Do not shy to use your network. If you cannot change your organization, like with the very big one, I tried and I failed, change your organization. Leading a team and evolving it, especially growing it, is very satisfying. And producing higher quality software that others might be bad for your business. So if you're in a contracting, consulting business, write crappy code. Gives you more billable hours. until I come called in and do a review, which I do from time to time. And working software lives much longer than ever intended. Agile. With the patterns, we also started agile. Test infecting was one of the things, and one big thing is what people do, they follow rituals. And that's not adhering to the values. Who is using Scrum? Who is using daily stand-ups? Most of the things are rituals. Rituals are bad if you do it because of the ritual. It's like religion. If you just do the rituals and not following the values, religion doesn't serve you anything. And the same with rituals of agile. The values are the important things. And why are rituals like daily stand-ups there? It's actually to practice behavior and facilitate stuff that might lead you to the values, but they are not a means, not the end. If I consider the most important things from Agile is unit testing, test-driven development, and doing it sanely and not only on a unit level. Refactoring and simplifying your design. If your unit tests go against your refactoring, refactor your tests. And the rhythm and feedback. Why do you do daily stand-ups? Not because you like to stand with holding your cup and listening to others babbling. No, it's because it gives your team a rhythm to think about what to do and to also think about what you achieved. And that gives feedback. If you achieve a lot and getting small steps with daily stand-ups, you can achieve a lot. You have the feeling, I achieved something. That's what I train my students as well. For each week when I meet with them, they have to do a checklist with more than 5 items that they want to work on the next week. And if they only check one of them, the items were designed to be too big. So rhythm is good. Why is rhythm good? In the early 1980s, I liked to dance in the discotheque, mostly to Italian pop, Italo pop. Albano and Romina Power. Ricci e Poveri. That's how I met my wife, so that's a good thing. The thing about, I'm not a musician, but dancing rhythm helps you to perform as a team, and the rhythm gives you the means to coordinate without thinking about coordination. If you have to think about coordination, it gets ugly and messy. And that's where rhythm is really helping you to coordinate, to advance, and to work together. And that's why rhythm is good, and rituals can help you to improve your rhythm. But you should go beyond the rituals and just have the rhythm in your blood, so you can dance without the music. And today I learned that people call themselves Scrum Masters because they take the class and got the sheet. And they do neither Scrum nor Master. A lot about stuff is about getting technology right. And sometimes life takes you off track. That's a BMW, by the way, Formula One in 2000. Why did I put that slide in? In 2000, exactly at that race when I took that shot, I figured out I had hematoma without hitting something. And it turned out I got diagnosed with leukemia. And that's after the major treatment. So this face mask and coverage is what all my visitors would look like for a couple of weeks or months. I went into isolation, got a bone marrow transplant. And actually the diagnosis after that GP race, when I went to the doctor to get a blood test, the next day I got called over lunchtime. I was teaching a design patterns class to an audience. And I got the diagnosis and I said, you have to go to the hospital immediately this afternoon, after you finish with your course. I finished that course, went there, started treatment with the kind of chemotherapy pills to take to get my blood cells in count into some range that was survivable. I would have died within a couple of weeks from leukemia then. And fortunately, as you see, I survived. I missed the Extreme Programming Conference, XP 2000, that time. And as I said, in January 2001, I got the bone marrow transplant. Fortunately, my brother was available as a donor. So if you're not registered as a stem cell donor in your local country, get registered. Give a small swipe of your tissue, and they will figure out and make you available in the bone marrow or stem cell donor database. That's very important because not everybody is as lucky as I am to have a large enough family with compatible donors. And it can actually help you survive. The treatment itself is very heavy dose chemotherapy. You actually get killed, and all the blood cells get replaced by the donor. So my blood, if I cut myself, the blood is my brother's. So I shouldn't be sorry if I bleed. It's no longer blood. That's how I look. The nice 10 came from actually my new immune system attacking my body. It's not a suntan. It's actually a bad thing happens. But after being out of the hospital, the broad neck is from the high dose of steroids, trying to get my immune system in check. I worked on security patterns, and I got a new convertible. And being self-sufficient, if you're a patient and appreciate help. As a patient, you're responsible for yourself, and be patient. It takes time to heal. Breaks are important. I needed to take breaks 4 times from one story to the next in my house to actually get there. And exercise your body, you only have one. That's also a guideline. In 2004, I joined HSR, and I speed up because I will skip everything, and you might learn about a lot. I was teaching a lot of software engineering, C++. I started teaching C++ in a more modern way. Was then considered modern. I taught concurrent network programming, patterns and frameworks, and I started student projects with IDEs because I still believed in IDEs and static analysis to give immediate feedback and to change your code without hassle. And I founded the Institute for Software. And my students seem to love me or hate me, whatever. I learned students have the right to fail, but if you ask a little bit more than a student seems to be capable of, it's the most rewarding thing for both parties. So always stretch the limits. Don't ask the easy things from your students to improve them. Also, my lifetime goal, I became clear of that. I want to eliminate bad software. I cannot shoot all the bad programmers, maybe except with the Nerf gun, which we also had in the office for some time. I need to change what they are doing. And one thing to change bad software is refactoring it. That's why we created refactoring tools. In 2005, when I told somebody, oh, I'm trying to do C++ refactoring, everybody told me, that's impossible. You're crazy. And I said, okay, I like to do crazy stuff because I want to change something. If I would try stuff that I know, oh, I have 5 minutes on my, okay. Ah, cheating. So we created that nice IDE that you can learn more about. I became an ACCU speaker, and more important, less code equals more software refactory to make your code simpler. I joined the ISO committee being drafted by one of the things, and unfortunately, I ran out of hats. Greetings from Bjarne. And we not only shared wine at the meetings when we had them in Rapperswil, but also bread. And I got an Audi, and I don't tell you the story why I got an Audi, but it was a fun drive. Especially it was about bad quality of BMWs at that time. You learn a lot being with bright people in the room. Even small contributions can be valuable. Keeping up to date with C++ evolution is hard. We are moving quick right now. And nobody knows everything about C++. Be humble. And be patient. It sometimes takes years for a good proposal to enter the standard. I'm now in, for unique resource, I'm now in revision 12 or 13, and I even found a bug in revision 11, a bug in the spec. Guidelines, refactor, refactor, refactor. I'm working on AUTOSAR and MISRA guidelines because the core guidelines have some bad corners, but they are good enough. No explanation about guidelines, and even if you follow the guidelines, somebody might kick you. An IDE, if you want to have good checking for guidelines and refactoring, an IDE can be much more powerful than a compiler-based tool. And you, where is JetBrains? Can't see her. There's a talk about how you can use the IDE to debug your code without debugging right now afterwards, I believe. And more C++ lessons, I skipped those. Maybe one thing, to make a polymorphic base class virtual destructor, delete the move assignment operator. That's the shortest means to make your class non-copyable. And if you don't know that, get the table by Howard Hinnant, learn it by heart, and consider this line. And that's my current car, and I'm looking forward to the next 35 years of programming, and I still have 2 minutes left for questions.